guys, welcome back to my channel. Nice to see everyone again. And to continue in this video, we are going to talk about topic 3.3 where we will discuss the preparation of alkenes. We're only going to talk about two things. One is the dehydration of alcohol, one of the methods to prepare alkene. Another one is we are going to talk the rules applied in this process. So we are going to talk about Saytzeff rules. It's a very simple video with a lot of examples. Let's see. So how can we prepare alkene? How can alkene produce? One of the methods is dehydration of alcohol. From the word dehydration, we know that we are actually removing water. We are going to remove water. Dehydration. So we are going to remove water from alcohol. That is actually what the entire process talks about. So what do we need to have? We need to have alcohol at the beginning as our reactant. And then with the presence of concentrated sulfuric acid, your concentrated sulfuric acid is your dehydrating agent. So this is the guy that will help us to remove the water. And then you need to have the presence of your heat. And then you will be able to produce your carbon-carbon double bond alkene and also the presence of water. And this is the dehydration process. You can see that we are removing water and produce alkene. Okay? So the general equation that I can give to you over here is your general alcohol. We will only focus on two carbon. The carbon that holding the OH and also the carbon that next to the OH. Only two carbon, only the neighboring carbon. And what happened is the OH will be removed. The H next to it, next to the carbon, will be also removed. So OH will be removed from one carbon. Another hydrogen will be removed from the adjacent carbon, the neighboring carbon. And then the double bond will be produced between the two carbon and producing water. So that is how you produce your alkene and also how you remove your water. Bear that in mind, you must have the presence of concentrated sulfuric acid and also heat for this process to happen. So what type of reaction is this? It's obviously an elimination reaction because we are removing water. We remove water or we eliminate water. That's why it's an elimination reaction. Simple. So we only focus on two carbon, the carbon that holding the OH and also the adjacent carbon, the neighboring carbon. Okay. So right now we know that we will be removing the OH and also the H from the adjacent carbon, the neighboring carbon. And we know that it's an elimination reaction. So we remove water and that is your elimination reaction. I want to remind you again that the OH and the H must be removed from the adjacent carbon. What is meant by adjacent carbon? Carbon that directly next to each other. So the adjacent carbon that I always say means that we must be taking the neighboring carbon, the carbon that directly next to each other, because your double bond must be like this. Alright? So when you remove the OH, we only check the carbon that on the left, on the right, or on the top. Only the neighboring carbon. Okay? Alright, we are not going to talk about the rest of the carbon back here. We will ignore all this. We only focus on one thing. The carbon that holding the OH and also the carbon next to it. Alright, just directly next to it. This one also can, this one also can, but not the rest of this. Alright, we are going to ignore all this. Bear that in mind. That is what we mean by adjacent carbon. The carbon directly next to each other. Last but not least, for your information, tertiary alcohol is easier to remove the water compared to secondary followed by primary. So if the alcohol is a tertiary alcohol, it's actually easier to remove the water compared to secondary compared to primary. And that's it about dehydration of alcohol. Simple, isn't it? So let's try examples. So this is my first example. If you look at it, the question right now gives you in the form of condensed. And the question gives you the concentrated sulfuric acid and the heat. Good. So what do we need to do first is expand this condense. And do we need to expand everything? No. We only expand the carbon that holding the OH and also the neighboring carbon. Alright, we only expand those that we want to look at. In the other words, other than that, we can leave it in the form of condense because we are not going to use it. Expand the neighboring carbon and the hydrogen. Expand the carbon that holding the OH. Alright, so you have one OH on this carbon. Expand the structure, then you will see it clearly. And next, what do? Highlight the carbon that holding the OH. So this is the carbon that holding the OH. Look at this carbon. We only want to focus on the neighboring carbon. On the right hand side, there is no carbon. On the top, there is no carbon. So on the left, there is one carbon. And make sure this carbon holding hydrogen. So we focus on the neighboring carbon and the hydrogen that it has. And next, what do? We are going to remove the H and the OH. And what would be your product? Those that doesn't involve in any changes, those that doesn't change, you basically just copy back. Your CH3 doesn't change. Alright? Your C and the H up here doesn't change. The single bond so far is still there. And then you have your carbon, you have your hydrogen, two of them doesn't change. And what is the new bond? The new bond is between the carbon that holding the OH and the carbon that holding the H. So that is my new double bond. Can you see that? Simple. And don't forget your byproduct. You are producing H2O as your byproduct. As your elimination process, this is what we remove. Simple, easy. Try naming for a bit. So that is your propene. Is your 1-propene. Simple. Let's try another example. You have this structure right now, more carbon. As I said, we were going to find the carbon that holding the OH first. And then the neighboring carbon. Next to it on the left, next to it on the right. We only focus on these two. So when you expand it, we don't expand everything. Those that not involved remain there. So you have your CH3 remain. You have your carbon holding 2 hydrogen. You have your carbon holding 1 hydrogen and OH. This is our hero. We are going to focus on the OH. And then you have your carbon holding hydrogen 2. And then you have your CH3. So as always, we focus on the carbon that holding the OH. This is your focus. Okay? Next, we have carbon on the left. We have carbon on the right. So which one are we going to choose? You can choose both, to be honest, with one condition, if they give you different product. So let's try on the left first. What happens if I remove the hydrogen from the left? So when I remove it from the left, I will be removing the OH. I will be removing the H. So as always, those that doesn't change, you basically copy back. This thing doesn't change at this moment. So we re-copy. You have your CH3. C, H doesn't change. Hydrogen down there remove. You have your new bond, double bond. So you have your C, H, because OH remove. And then you have your C, H doesn't change, remain. And then you have your CH3. So you have your structure over here given the first product where the double bond is produced between these 2 carbon because you remove the OH and the H from these 2 carbon. So that is your new double bond. And the name for this guy will be your 2-pentene. Okay, simple. So let's see what happens when we remove the hydrogen on the right carbon. Same thing, we will focus on the carbon that holding the OH. This is our focus, definitely. And just now we remove on the left. So let's try if I remove on the right. So if I remove hydrogen, okay? So this is the 2 carbon that we will focus on. There will be leaving, there will be leaving, going out. Bye-bye. So you have this guy remain, and be there. Okay? So we recopy the thing. You have your CH3. You have your CH. you have your CH, OH remove, so you form a double bond, H bottom remove, so you have only one H left, and then you have your CH3. So, is our structure above and the structure below the same? Look at the naming, then you'll realize it's actually the same. The below one is also 2-pentene. In the other words, both of them are actually the same. If both of them are the same, do you need to write twice? No, we only write one time. In this case, removing the hydrogen from the left carbon or removing the hydrogen on the right carbon is the same because they will produce 2-pentene both ways. Okay, simple. Okay, is that clear? So if they give you the same product, we do not need to write the product twice. We will only write it once. Okay, and don't forget your byproduct H2O. So simple. Focus on the carbon that holding the OH. Remove hydrogen on the adjacent carbon, on the neighboring carbon only, so that you can form a new double bond between the two carbon. Easy. Alright. Let's look at more example. Moving to your cyclic at this moment. So you have your OH over here. We know that the carbon that holding OH is this. So you have your carbon holding OH. The adjacent carbon, the neighboring carbon can be this, can be this. So as always, we will try to expand the structure, but only the adjacent carbon. So you have your OH over here. The adjacent carbon holding 2 hydrogen. Knowing that this carbon will definitely remove the OH right now. Forming double bond with the left carbon or forming double bond with the bottom carbon is actually the same. I hope you realize that it's actually giving you the same cyclobutene. So let's try on removing the hydrogen on the left. Knowing that your OH will be removed, your hydrogen next to it will be removed. So your new double bond should be between here. So let's draw our new double bond. You will have this structure cyclobutene. Your double bond will be on this side because you remove the OH and you remove the H. Therefore, you have your cyclobutene produced. And don't forget your byproduct H2O. You are removing the water. And you actually realize that it will be the same even you remove the hydrogen at the bottom. Only the position of the double bond will be different. The double bond then will be located on this bond because you are going to remove the OH and the H at the bottom. But the product produced will be also cyclobutene. It's the same. Can you see that? They are the same. Therefore, do we need to draw this again? No, since they are the same. You can choose whether to remove the hydrogen on the left or hydrogen on the bottom. Up to you because they are the same. Alright, I hope you get it. It's very easy. Let's move on to something harder. Another example that I have over here is you have more carbon, but don't worry, we will still focus on the carbon that holding the OH. And then you realize that this carbon that holding OH having a lot of neighboring carbon. We have on the left, we have on the top, we have on the right. So what do is you expand all your neighboring carbon. So those that you do not need to expand, we remain it as a CH3. You expand the neighboring carbon, the carbon that holding the OH, the carbon at the top, the carbon on the right. But after all, we still focus on the carbon that holding the OH. And I have 3 neighbors right now. Which one do I remove? Let's start from the left. So if I start from the left, means I will remove the hydrogen that's sitting on the left carbon. Okay? Knowing that the OH will be removed, the H right now also will be removed. The new bond is between here. Okay, agree? So you have your first CH3 remain unchanged. And then you have your carbon having only 1 hydrogen left because you form a new double bond with the carbon that holding the OH. And the CH3 at the top and also the CH3 at the corner doesn't change. So that is your first structure. So try to give name to this guy. The rules of naming, you have it in your video 3.1 and 3.2, so you can watch that. And I'll just give you the name straight. It's a 2-methyl 2-butene. So that is the name of your first product. But we know that our structure having another 2 neighbor. I can remove the hydrogen from the top carbon also. So let's see what happened that I remove from the top carbon. So when I remove the hydrogen from the top carbon, knowing that the hydrogen will be going out, the new bond will be formed between this carbon. So those that doesn't change, this guy doesn't change, remain unchanged. So you have your another product, CH3, doesn't change, CH2, doesn't change, and then you have the carbon that holding the OH, remove the OH, form double bond with the top carbon. The top carbon will only left with 2 hydrogen. And also on the right, you have your CH3 unchanged. And try to give name to your new butene. So your new butene will be 2-methyl also. But the double bond right now is located on the first carbon. So the parent will be only butene. Can you see that they are different? The position of your double bond right now is different. The position of double bond is on the second carbon. The position of this double bond is on the first carbon. Okay, so it's a 2 different structure. So both is correct here. Both is acceptable. We have another neighbor, guys. We have another neighbor on the right. What happened when we remove hydrogen from the right carbon? Removing this hydrogen at this moment, knowing that it will be going out, the new double bond will be between these 2 carbon. Okay, so you have your CH3, CH2, carbon, holding OH is now gone. Up there still have a CH3, forming a new double bond between this carbon holding 2 hydrogen. And what will be the name of this? The name of this will be the same as your second structure, which is 2-methyl butene. Why is that the same? The position of your double bond is also on the first carbon, your methyl on the second carbon. Can you see that? Your first carbon over here, that is my second carbon. So your methyl group is on the second carbon. Your methyl group also on the second carbon. So 2-methyl butene, 2-methyl butene is the same. Since it's the same, do we need to rewrite that? No. So you can skip this and no need to write this again because it's the same. Alright? Simple. Easy. In the other words, removing hydrogen from the top carbon or removing hydrogen from the right carbon will give you the same product. But remove from the left carbon over here, removing from this carbon will give you different product. This one must be there. This 2 will be all. You can either remove from the top or remove from the right. And this is the 2 product that you produced. And don't forget your byproduct where you have your H2O. Simple. Alright. So right now you have 2 product. Okay. Your question right now will give you 2 type of alkene. Let's try another example. So you have a cyclic. You have your OH. So the carbon that holding the OH is here. Alright. And do you know how many neighboring carbon that you have? You have 1 neighboring carbon. You have 2 neighboring carbon. You have 3 neighboring carbon that can remove hydrogen. So don't forget that you have the presence of concentrated sulfuric acid and heat over here for this dehydration of alcohol process to happen. Expand the structure, but we only expand the neighboring carbon and also the OH only. The rest, no need to expand. So you have your cyclic. The neighboring carbon, you're having hydrogen. You're having hydrogen. Over here, you have your C holding H3. The same carbon on here holding OH. And another neighboring carbon is at the right hand side holding hydrogen. Expand the carbon that you want to look at only. Remember that. Don't expand everything. Going to be a mess. So the carbon that we will focus mainly is the carbon that holding the OH. And then you have 3 neighboring carbon, guys. The first neighboring carbon that you can remove the hydrogen. The second neighboring carbon that you can remove the hydrogen. You can remove this hydrogen also. Another one, this neighboring carbon, you can remove the hydrogen also. Can you see that? So you have 3 neighboring carbon, you have 3 adjacent carbon that holding hydrogen that you can remove and form double bond. So let's look at the first one. Let's look at the green color. What happened when I remove the hydrogen here? The OH will be going out. So right now, hydrogen going out on this. So the new double bond will be formed between these 2 carbon. So the first product that you produce will be cyclohexane, double bond at the top, OH removed already, so you have CH2 remain, and that is your first product. Okay, let's try remove the second carbon that you can. So let's try remove the hydrogen in the blue color. So your neighboring carbon that you want to remove is this. Remove the hydrogen over here. So the new double bond will be formed between these 2 carbon. Right? Agree? Because that is the carbon that removed the OH. That is the carbon that removed the H now. So your new product will be the double bond is between these 2 carbon. Have removed the OH. So there is no OH left. But the CH3 is still there. They are different. Can you see that? They are different product. You have another neighbor that you can look at. The another neighbor that you can look at is the yellow color hydrogen. So you can remove this hydrogen right now. Another neighbor of carbon, another adjacent carbon that you remove. So the double bond form over here because you are removing the hydrogen from the right adjacent carbon. And your another product could be this. But do you realize that this is actually the same? Both of this will be named as methyl cyclohexene. So both of this is actually your methyl cyclohexene. They are exactly the same. Alright? Since they are exactly the same, do you need to rewrite it again? No, don't waste your time. Okay? And you are done with the presence of H2O. You remove water. Okay? Simple. So we have 2 products of alkene produced over here, even though you have 3 neighboring carbon. I want to remind you one thing. It's not necessary for us to remove hydrogen from all the neighboring carbon. It's not needed to remove the hydrogen and form double bond with all the neighboring carbon. If the neighboring carbon produce the same product, then we only write one time because they are exactly the same. We are going to write the product. If all the products are different from each other, then we are going to write them out. Bear that in mind, not all the neighboring carbon. We will only choose them if they're able to produce different alkene. Okay? Moving to the next thing. So right now in the dehydration of alcohol, you can produce 2 or more alkenes. When you produce 2 or more alkenes, which one is actually major? Which one will be the minor product? Simple. We have Saytzeff rules. Saytzeff rules is the one that determines which one is the major product, which one is the minor product. So let's see what Saytzeff trying to say. Saytzeff mentioned that in an elimination reaction, we remove water if you remember. So in the elimination reaction, alkene with highly substituted double bond is the major product. Major product when highly substituted double bond. So what is meant by highly substituted? If I have a carbon-carbon double bond over here, highly substituted double bond means the double bond that holding more alkyl group. More alkyl group means more R group is what we call alkyl group, and the easiest sentence is what we call carbon group. So the more the carbon group, the highly substituted is your double bond. In the other words, if I'm giving you example like this, I have a CH3, CH2, I have H and H. Over here in this structure, we have 2 alkyl group, 1, 2. So over here, you have 2 R group, okay? Compared to this compound, compared to this double bond might have something like this. Even though that the carbon group is very big, but we only take this as 1 carbon group. So, 1 carbon-carbon double bond, a pair of carbon-carbon double bond can have 4 bonds. So maximum you can hold 4 carbon group. Over here, you have 2 carbon group. Over here, you have 1 carbon group, 1 R group, okay? Your R group over here. So which one is more stable? Which one is highly substituted? This is highly substituted, all right? This will be your major product. This will be your minor product. So major and minor will depend on how many carbon group you are having, not how big is the carbon group. The more carbon group you have, the highly substituted they are, more stable they are, that's why they are major. Okay? We are talking about how many R group. We are not talking about how big is the R group. We don't care whether it's big or small like this. Okay? It's a very big R group, but it's only 1 R group. It's still 1 big R group, but it's just 1. And I have 2 R group over here. So 2 R group is definitely more highly substituted. That's why they become major. Alright, so we only focus on the carbon-carbon double bond and how many R group is the carbon-carbon double bond holding. Alright, the higher the R group, the more stable they are. They will then be the major product. So let's see my example over here. This is my double bond. So for this first structure, you have 1 R group, 2 R group, 3 R group, 4 R group. So in this 4 R group, alright, it's a very highly substituted. That's why it's the most stable. And that will be your major. Next, you have your double bond again over here. But look at how many R group you have. You have 1 R group, 2 R group, 3 R group. So you only have 3 R group. So this 3 R group will be less stable than this guy. Okay? So between these two, this will be major, this will be minor. Can you see that? But that in my R group that I mean over here is actually what we call alkyl group. And the alkyl group is actually carbon group. Alright? And we don't care how big is the carbon. 1 carbon or 10 carbon is still 1 group. Okay? Next, when you have 2 R group means, look at your double bond. That is your carbon double bond. And in this case, you have 2 R group only. Next, that is your carbon-carbon double bond. And you only have 1 R group. Last but not least, look at your carbon-carbon double bond. And this carbon double bond don't have any R group. All of them is only hydrogen. So this is the most minor. This is the most major. Okay, that is the number 1 major. That is your number 2 major. That is your number 3 major. Number 4. And this is the least major. That is your minor. Okay, because the number of R group. You have 4 R group, 3 R group, 2 R group, and 1 R group. So the more the R group, the more stable it is. That will definitely be your major product. And that is what Saytzeff trying to say. So, going back to the question that we produced 2 products just now, let's see which one is the major and which one is the minor. So look at the double bond. Only focus on the carbon-carbon double bond. Okay, that is the way. And you realize that your carbon-carbon double bond will be holding 4 bonds. Can you see that? The first bond, the second bond, the third bond, the fourth bond. And count how many bonds is bonded to carbon. So this bond is bonded to carbon. This bond is bonded to carbon, bonded to carbon. Hydrogen. So you have 3 bonds that bonded to carbon, 3 alkyl group. Over here, this is my carbon-carbon double bond. The first bond, the second bond, the third bond, the fourth bond. So the first bond is hydrogen, so no. The third bond is carbon. The fourth bond is carbon. So you have 2 carbon group over here. So guys, 2 carbon group and 3 carbon group. Which one will be your major? Automatically, this guy will be your major product. This guy will be your minor product. And my advice is, write the major and minor even though the question did not ask for it. Whenever your question have more than 1 product, always label which one is the major, which one is the minor. The easiest way is highlight your double bond and then you look at the other 4 bonds is bonded to carbon or not. We don't care how many carbon back there. We only care is it bonded to carbon. Alright, whether it's 1 carbon or 10 carbon, it's still 1 carbon group. Remember that. Another example that we discussed just now, Same thing, guys. We'll focus on this. Highlight the double bond. Okay? And then check the 4 bond. So, not hydrogen. This is the 4 bond that you check. 1, 2, 3, 4. Okay, that is the 4 bond. So, not carbon, not carbon. Carbon, carbon. So, you have 2 group. 2 carbon group. So, this is the carbon that we are looking at. This is the carbon that we are looking at. This carbon, the 2 bond that we are going to look at is this. This one, 1. One more is actually hydrogen. If you remember, every carbon having 4 bonds. So the bond that is not enough is actually your hydrogen. So hydrogen, we are not taking count. This bond is a carbon. So yes. This bond is a carbon. Yes. This bond also a carbon. So yes. So you have 3 R group over here. Okay. Carbon, carbon, carbon. 3 alkyl group, 2 alkyl group. 3 alkyl group is the major. So this guy will be the major product. This guy will be the minor product. And like I said previously, it's better for you to label which one is major, which one is minor. Okay? Simple, right? So let's try another example over here. And if you look at my example now, you realize that I didn't put your dehydrating agent and also your heat. So make sure you have your dehydrating agent. Concentrated sulfuric acid is acceptable. Alright, the heat can be replaced by symbol triangle. So that is your dehydrating agent and also your heat. And then as always, you highlight the carbon that holding the OH and also the neighboring carbon that you are going to look at, because we are going to expand all this. But you realize that the big group that doesn't involve, we do not need to expand. Just leave it there. So expand what you should expand. And then you have your carbon that holding the OH, carbon that holding 2 hydrogen, and the rest do not need to expand because they are not adjacent carbon. They are not neighboring carbon. So ignore them. Alright, they are for display purpose only. You just copy. So as always, we identified the carbon that holding the OH. That is our hero in this. You have 2 neighboring carbon that you can remove the hydrogen from. The first one is on the left that you can remove the hydrogen. The second is on the right that you can remove the hydrogen. Okay, you can remove both of this hydrogen and we will see whether they produce different product or not. So first, let's try to remove the OH. We are going to remove the OH and remove the hydrogen on the left. So removing the hydrogen in the green color. And the double bond will be produced between these 2 carbon. Between the 2 carbon that remove OH and H. And your new product will be carbon, hydrogen, hydrogen, forming new double bond. Carbon, hydrogen, OH out, hydrogen out. And then you have your CH2 that haven't do anything. And then you have the rest of the big group back there that pretty much do nothing. So that is my first product. And let's try to look at the second possibility. The second possibility is to remove the hydrogen on the right hand side. Is to remove the hydrogen in the blue color. So the hydrogen in the blue color go out. And the new double bond will be between the carbon that remove the OH and the H at this moment, which is here. And your new product will be CH3. At this moment, do nothing. The carbon that holding OH, remove the OH. Form a new double bond with the carbon that holding the H. And also CH3. The rest of the group that pretty much do nothing, right? And you have your 2 products over here. And obviously, these 2 products are different because the position of the double bond is so different. The double bond on the first compound is on the first carbon. The double bond on the second product is on the second carbon. So, it's obviously a different product. Therefore, we'll be taking both of them. And please don't forget the byproduct H2O that we removed just now. Alright. And next, if we have 2 products, what do? We need to identify who is the major and who is the minor. So that is my double bond. We highlighted our double bond already. So we need to check the 4 bond that the carbon-carbon double bond holding is bonded to carbon group or not. So the first compound, the first product, not carbon, not carbon, not carbon, carbon. So you have 1 carbon group, 1 R group. Okay. The second product, So the 4 bond that you will look at is this 4. Okay? The bond that the carbon-carbon double bond holding. So 1 R group, not R group, not R group, 2 R group. So you have 2 R group. So who is your major and minor when you have 1 R group and 2 R group? Obviously, the 2 R group will be your major product. That is your major product. And this will be automatically your minor product. Make sure you label them whenever you have more than 1 product. Let's try one more example and the last one. So, your dehydrating agent, other than concentrated sulfuric acid, it also can be concentrated phosphoric acid. Don't forget this. And then you have the presence of your heat. You can either write the word heat or you can use symbol. Both are acceptable. And as always, we are going to focus on the carbon that holding the OH. And we have neighboring carbon. We have 2 neighboring carbon over here. 1 on the left, 1 at the bottom. And as always, guys, we are going to expand those that we need to expand. So expand the OH. Expand this carbon. Why I say you need to expand? Because this carbon is actually holding another hydrogen. This carbon need to have 4 bonds. There is only 1, 2, 3. 1 more bond is actually your hydrogen. So over here, you have your hydrogen. You have your hydrogen. See that? Simple. So this is the carbon that holding OH. We know that this OH will be removed definitely. The first possibility of hydrogen that you can remove is on the left hand side, the carbon in the green right now. The second possibility that you can remove is the carbon in the blue right now, the hydrogen in the blue right now. That is the second hydrogen that you can remove. Let's start with the left one. So let's start off with the left one. If I remove the OH, definitely, I can remove the hydrogen in the green, which is on the left adjacent carbon. And the double bond will be formed over here. This is my double bond. So let's draw your product. Your product will look something like this. The CH3 doesn't change, guys. The CH3 doesn't change at any cost at this moment. So the hydrogen remain 1. You form a double bond over here. The hydrogen here also do nothing yet. So that is your first product. That will remove the hydrogen in the adjacent carbon in green. So that is your first product. The other possibility is you can remove the hydrogen from the adjacent carbon in the blue. So you can remove this hydrogen and the double bond will be formed in here between the carbon that removed the OH and the carbon that removed the hydrogen over here right now. So your another product will be your cyclic. CH3 doesn't change again and the double bond is here. Alright? So the hydrogen that you have over here doesn't change. Nothing changed in this carbon because we are not removing anything from this carbon. Alright? And don't forget the H2O. So bear that in mind, they are plus because they are all different products. You can see that the position of the double bond will tell you that they are different products. Alright? It's very easy to identify whether they are the same product or not is by naming them. When you give the name, then you realize that there will be different products. Over here, this one will be your 3-methyl-cyclobutene. This one will be your methyl-cyclobutene. Since they will give you different name, therefore they are different product. And since you have more than one product, what do? Don't forget to label major or minor. So identify the major minor now. So this is the 4 bond that we will look at. Alright, the 4 bond that the carbon double bond holding. So 1 more is actually your hydrogen. If you remember, because there is not enough bond, so 1 more is definitely your hydrogen. So hydrogen, we are not taking count. Hydrogen, we are not taking count. Over here, that is your carbon. So yes, 1 R group. That is your carbon. So yes, 2 R group. Over here, you have 2 R group. For this one, the carbon double bond, this is your carbon double bond. The first bond that we will check. The second bond is actually your hydrogen again. And this is the carbon. This carbon, first bond, second bond. So, hydrogen not taking count. Carbon, yes. Carbon, yes. Carbon, yes. So, you have 3 R group. So, 2 R group and 3 R group, guys. Again, who is your major? Who is your minor? Always remember the one that attached to more carbon is your major. So that will be your major because it attached to 3 alkyl group. And this will be your minor because it only attached to 2 alkyl group. Simple, easy. So that's it for dehydration of alcohol and Saytzeff rules. Don't forget dehydration of alcohol, we definitely focus on alcohol and also the reagent and condition. Please don't forget the byproduct water. Water is equally important as your product alkene over here, okay? If you have more than one product, make sure you label who is the major and who is the minor by using Saytzeff rules that you have learned. And in the entire video, you only learn 2 things: dehydration alcohol and Saytzeff rules. So make sure you understand them very well. And if you have any question, drop in the comment below and I'll get back to you as soon as I can. Thank you for watching. And don't forget to like the video and subscribe to my channel. I shall see you in the next video.